Welcome to the video on common and natural logs. In this video we'll be talking about two logs that we'll be using a calculator. So let's go over the common log first. So the definition of a common log basically is a log that has a base of 10. And we call it the common log because if the base is 10, we don't write the log with a base. So if you find a log that kind of looks like this, like log and then just a number, we assume that the base is going to be 10 because that's what the common log is. And on your calculator, you'll find a symbol that says log, and this is on scientific calculators. You can find one on your computer, probably one on your phone. And if you find a key that says log, that's the common log function. There'll be a different function for the natural log, which we'll go over a bit later into the video. So there's one very important formula that we have to remember when we use common logs, because a common log, remember, is only base 10, which means you can't enter a base when you use a calculator, because the only base that the calculator reads is base 10. So if you're trying to find something like log base 6 or log base 12, you'll have to convert it into logs that have the base of 10 so that you can use the calculator. And the way you would do that is using the change base formula. So if log base a of x, if you have a log, then that's equal to log x over log a. So basically all you do is you make a fraction, you have this one on top, this one on bottom, and they're both logs. So let's try that out. So we have log base 6 of 18. So that's equal to log of 18 over log of 6 according to the change base formula. So now what we can do is we can pull out our calculators and we can enter it in. So we have log of 18, this is the log key right here, log of 18 divided by log of 6. And that's equal to 1.61314719276, and goes on and on and on. So approximately it's equal to about 1.6. So let's write that. So this is equal to 1.6, about 1.6. So let's try the second one here. That's also very, very similar to what we just did. So first we use the change base formula, and we get log of 5 over log of 12, and we pull out our calculators. We have log of 5 divided by log of 12, and we get about 0.65. And that's our answer. So finally, before we end our discussion on common logs, let's do this problem really fast. So we have 12 to the 2x is equal to 1,000. So how are we going to find that and then use a calculator to find the exact value? So first what we're going to do is we need to get rid of this exponent here. So what we're going to do is we're going to basically log both sides. So basically what we're doing is we're going to make both sides into a log. So log 12 to the 2x is equal to log 1,000. So remember, this isn't log base 12 of 2x. This is actually log 12 of 2x. So we assume that there is the base of 10 here. And since you have a log right here like this one, we can use the power rule and move this exponent right here, the 2x, as a coefficient. So let's do that. We have 2x log 12 is equal to log 1,000. So if we have a multiple of 10 that we're logging, then it should be really easy to find the value of this, actually, because if all common logs have the base of 10, and the powers of 10 are really easy because 10 to the power of 1 is equal to 10, 10 to the power of 2 is equal to 100, 10 to the power of 3 is equal to 1,000. Basically, the rule that you can remember for powers of 10s is that if you bring whatever power you bring 10 to, that's how many zeros there are. So since we're logging something that has 3 zeros, we know that's 10 to the power of 3. So we can simplify this log into just plain 3. So we have 2x log 12 is equal to 3. Now we just use our rules when we solve for variables, and that's to isolate the variables. So we're going to have x equals, and then we're going to divide both sides by 2 log 12 to get rid of all this other stuff and just leave x alone on its own side. So we're going to add x is equal to 3 over 2 log 12. So we basically just divided by log 12, and we divided by 2. So that x is alone on this side. So now that we've got a simplified value for what x is, and the base of the log is 10, we can now pull out our calculators to find the value. So if we do that, we have 3 over, and remember, if you're using a basic calculator, you have to make sure you add the parentheses, because if you don't add the parentheses, what it's going to do is it's going to do 3 divided by 2 first, and then multiply that by log 12, which is not going to be the same answer as what you should get. So make sure to add the parentheses when you have multiple things that you have being multiplied in the denominator. In this case, we have 2 and log 12 that are being multiplied, so you should add the parentheses in the denominator. So we have 3 over 2 times the log of 12. And now press enter, we get approximately 1.39. So natural logs are basically logs that have the base of e. And e is this irrational number that is approximately equal to 2.71. And basically how you get it is you do 1 plus 1 over n whole squared, whole to the power of n. So basically, as you increase the value of n, and n keeps getting bigger and bigger and bigger, you eventually get this irrational number called e, which is approximately 2.71. So the key on your calculator that uses the natural log is the ln key. And when you do that, it's just like when you use the common logs, it'll be a log with the base of e. So ln 8 is basically the same thing as log base e of 8. So basically, everything that we've done up to this point applies to natural logs. The logarithmic rules, all the stuff that we did. So let's simplify this and find x. And when we have e to the negative x is equal to 3, let's find what x is. So the first thing we do is we make this into a log. So we have log base e to the 3 is equal to negative x. So we know that when we have a log with the base of e, that's the same thing as ln over here. So we basically have ln 3 is equal to negative x. And to isolate negative x, we divide both sides by negative 1, and we get negative ln 3 is equal to x. So you pull out our calculators, and we get negative ln of 3 is equal to negative 1.0986, and so on. So that's approximately negative 1.1. Alright, so let's do the same thing for this one. E to the 3x is equal to 8. So same steps as we just did. So we're going to change this into a log. Log base e to the 8 is equal to 3x. And then we isolate the variable. Divide both sides by 3. And we get x is equal to log base e of 8 over 3. So we pull out our calculators, and we get 0.69314 and so on. So that's approximately 0.7. So that is what the natural log is. Oops, I forgot. This is still in the form of log base e. So we can change this into ln 8 over 3. So that ends our video on common and natural logs, and this is what we'll be using when we use our calculator to find the value of logs. So thanks for watching.